are not all adhesive tapes similar or the same. Where's the difference? They look different. They have different colors: yellow, red, blue, white, whatever. They have used paper as a carrier material, PE foil or a spun bond. But I can tell you there is quite an interesting difference. And the difference is you found in the glue which is used. I think that 95% of the tapes available in the market are produced out of so-called acrylic dispersion glue. Acrylic dispersion glue is produced this way, that you bring on the carrier material a liquid which is white, as you see it here on these pictures. And this white liquid you see here is a dispersion which has the following ingredient: acrylics. These are these red circles which are solved into water. Water is the blue parts. And normally, not in all, but I guess in most of the acrylic tapes, they put a lot of resins in. Resins are these yellow parts here, and resins are, as you know, when you cut into wood and the wood is producing the resins, it's a very sticky material. So they put it inside to make these tapes stickier to the sun, stickier to bad surfaces, and to avoid that the acrylics are swimming above or up in the water, and the resins are down in the water. We have to bring emulsifiers in. So, and the emulsifiers are responsible that you have a constant mixture, a constant dispersion. And what happens now during the production? So you bring it on the carrier material in a defined thickness, and then you bring heat to the liquid, and then the water is evaporating away. And during the drying process, dispersion is turning from white into crystal clear. Here you see that it's drying, and when all the water is out of the dispersion, it's crystal clear. As long as you have some water content in, it's white. And after the whole humidity is gone, it looks like the glue most of you know from this acrylic dispersion tapes available on the market. What happens when the acrylics get in contact? They are creating long molecular change. Then you have, besides this acrylics, you have this resins in. And resins, I made the picture before, it's something you know from wood. When you cut into wood, resins are coming out. And then they are extremely sticky. But what happens if you wait a couple of months or a couple of years? What happens with the resins then? They get brittle. And there are some resins used in these acrylic tapes which are endowed to be long time age resistant. So maybe somebody of you knows these hooks you can stick in your bathrooms to the tiles to put your towel on or whatever. And these glues are sticking normally very aggressive. So when you put it to the tile, you cannot remove it. But what happened after 5, 6, 7 or 10 years, sometimes they are falling off, and when you take a look at the backside of the glue, you see, oh, the glue has turned to yellow. And this can be the reason, this can be the reason when they use resins which are not age resistant. And for us, it was clear, we do not want to work with the glue technology, which are using a lot of resins, which are in doubt if they are age resistant or not. Some producer says we have acrylic-free acrylic dispersion tapes, or they say our resins are age resistant. It might be, but for us, of course, we like things that we can control, and so resins was not the first option for us. The second problem we have is we still have the emulsifiers in, and emulsifiers had only the reason to create a stable mixture. So the only purpose for them is to put moisture around them. And if an acrylic dispersion tapes is getting in contact with moisture again, the emulsifiers do what they have to do. They react with water. So when they get in contact with water, they are putting water around them. And do we have humidity on the building site? Yes, we have. And of course, this moisture is not good for dual connection. And so we said, we want to have something different. We do not want to have resins in which are not maybe not age resistant enough as we like them to have, and we do not want emulsifiers inside which are reacting with water, because we want something absolutely different. And so we found the Pro Clima solid technology. So it's the same, it's acrylic tape, but it's a solid acrylic. And the production is quite similar. We have this jumbo roll of carrier material. In this case, you see on this image the Teflon where there are a couple of thousands running meter on it. And then we coat the Varna with pure acrylics. We bring the acrylics to the carrier material, and the acrylics are more or less like a very liquid honey. Not very strong, they're like honey. It looks on the tape like this. Small acrylic chains which are not bounded with each other. So it's a special mixture, a special chemical process to produce it, but this is what we do. We just bring it in pure acrylic to the material. Then we are creating, by bringing energy, special energy to the tapes, to the glue, the acrylics are connecting with each other. And depending if we bring a lot of energy, a low energy to the glue, to the acrylic, to the solid acrylic, we have a softer or a harder glue. So we have a good influence which glue do we want to produce. Good. So you see it. We bring energy on it, and then we're creating the bonding, and this is how we are dealing with the glue. And the good thing is that due to the fact that acrylic, they cannot be dissolved into water without emulsifiers, we get an absolutely water-resistant glue. The question is now, okay, how does a tape stick? When we want to get a connection between the surface, the glue itself must stick to the surface. So this is called adhesion. So we need a good connection to the surface, and then the force must be transported through the glue itself. So the glue must offer a certain strength itself, and this is called cohesion. What is adhesion? Adhesion is very simple. If we bring two surfaces very close to each other, surfaces, because of the different electronic molecules found on the surface of it, it can create a connection with each other, which is called adhesion. Besides adhesion, we achieve a connection to the surface by the flowing of glue in the membrane structure. So when we take a closer look to the membrane, the microscope 300 times enlarged, you can see this is a PE foil. Yeah, it's not, you see it's a structured surface. Or when you take a look, next slide, on the Solitex, you see the small, nice fibers out which spunbond is produced. Or here you have a picture of the Intello. So it has alleys and valleys and hills and alleys. So it's not structured. And if the glue follows the structures and it's floating all around it, and if we want to remove it, the glue has to float out of the structure, and by this we achieve, besides adhesion, a mechanically connection to the surface. And this is why it's important, and the glues, independent if they are acrylic dispersion or solid acrylic, they are so-called PSA glues, so pressure sensitive adhesives. So we have to press them into the surface because we want to have bring them close together to have adhesion, and we want to press them in the structure to have the micromolecular connection between the surface. If we work with adhesive tape, gives them time to glue. The glue needs time to penetrate into the surface to create a good bonding. So here you see Warner, Tescon Warner, the at-once adherence, which is quite good, but you see a clear difference between the at-once adherence, and if you wait 6 hours contact time, then the bonding is getting stronger and stronger over time. So the test some people do, just stick it to the surface and try immediately to remove it. It does not respect how a glue is really working. Second point is cohesion. We are working with very big thicknesses of glue. So we are working with 200 grams per square meter, which is nearly half a pound per 10 square foot when I calculate it very fast to US. And this is quite high, and so we need a certain stability of the glue, that the force can be transported through the glues from one part of the connection to the other. Cohesion is, the definition is a molecular force between particles within a body or substrates that acts to unite them. To make it easier to understand, we have to jump to the next slide. You can take, on the one hand, a very liquid honey. Everybody knows it. When you go with a spoon into the honey and you turn the spoon around, what happens? The honey is dripping down, and only a very thin layer of honey remains on the spoon. So this is a material which is very sticky, so has a good adhesion, but a low cohesion, because the honey itself has no inner strength. The other extreme is hard concrete. That, of course, it's sticking to no surface, but it has a very strong cohesion. So, but the question is, the perfect airtightness tape or glue, which force must the tape resist? Should it stick to the finger? This is a test everybody is doing. Everybody normally takes the tape, removes the transfer liner, puts the thumb in, and then you think it's sticky or not sticky. Or must it resist short and long, strong and short tear forces? So it's another test. People stick it on the surface and then they tear very strong on it, and then they see it's sticking good or not. Or must a tape resist small but long-lasting forces? Yeah, for the building site, it's clear the answer. This is what we found on the building site. So we have the membrane sealed and the insulation is pressing to the connection. On the next image you see it better. You have the battens to support the insulation is pressing with very low force but for a long time to the connection. This is a tape which is extremely sticky. So when you make a test and somebody gives it in your hand and say, test it, you would say, wow, the best tape I've ever tested. And the reason why the finger tack is for some tapes better than with others is, or you can achieve a better finger tack when you make the glue softer, more into the direction of honey. Then the glue penetrates very easily in the structure of your fingers, and if you try to remove it, it gives you the impression it's a good glue. But you see what happens here on site. They've used these tapes and they wanted to press the insulation material a little bit into place, and they had tension. So tension on the connection, and you see that the glue, because it's so soft, started to swim. And yeah, it will collapse after time. So the glue is so soft, then you see it even on the membrane here and on the timber of the roof. So it's a very soft glue, not really good for airtightness. What you can do, every one of you, is to make this very simple test. You just take a PE sheet, 1 inch height, 2 inch, just cut it out of wood, half a pound, 250 grams. So half a pound, staple it to the timber, make the connection, make here a little mark with the pen, and let it hang. So this is a test done in my office. This is Anna and some other air tightness tapes, and you can see what happens after 24 hours. You see that first of the tapes, they started to move. After 48 hours, yeah, one connection, one tape, yeah, was close to collapse. Good. Of course, why have I chosen these 4 tapes? Because I know good and bad tapes. Why do I know them? Because we made one long-term in our lab or in the basement. You can see it on the next slide. So we bought all available tapes, or not all available, but a lot of these tapes available in Germany. And then we put this weight on it, and we want to see, okay, how long do they last if they have a permanent stress by this 250 grams? And this picture I made 3 days later, so you see the 3 tapes which already collapsed even after 3 days. But we let it hang for a long time. So after 3 years, only 5 tapes from 56 are still resisting the force, and all Pro Clima tapes are still hanging. Why is it? Because we optimized our glue to cohesion and not to the finger tack to convince people to a fast buy. So we said, okay, for us it's important that we produce tapes which are resisting the forces we found really in the lifetime in the building. It's only seam to stick. Normally they have a low cohesion. Good glues combine initial tack with a good cohesion. So this is what you always keep in mind. Think on the honey the next time you check adhesive tapes, and think about the test I've shown you.